Hey folks. Edge Security PKI Unleashed, the secret handshake. That's the talk track for today. I think this is my second or third Hashi Talks. Glad to be back part of the program this year. And so, just to open, why did I pick this talk track? And so, as a technologist, you're kind of watching the industry, you're kind of watching the market, you're watching all these things changing and evolving. We've seen a lot of change in the last decade, 15 years, and it just seems to speed up all the time. We're hearing all these new use cases we never even thought of. We're hearing more about 5G, you're hearing more about IoT. Last couple of years, it's all AI, ML, and mech and running things on the edge. And I think it's really interesting because there's all these new ways to do things, and we got to stop and think, how are we going to do this the right way, and not do what we have always done with security being an afterthought. And so when I look at this, I think about my time early in my career when I was working in organizations rolling out data centers. And one of the fundamental aspects of security then was the four walls of your data center. You build the four walls, you build an ingress and egress, and those were kind of your control point. Then all of a sudden we started talking about SaaS, and organizations started adopting this, and those controls got a little weaker. Go a little further, we start seeing more adoption of public cloud at Google, at Amazon, at Microsoft, and the four walls are almost evaporated. Take that a step further, and you're talking about this edge computing. Well, edge could be anywhere from in a colo at a data center at a telco edge, or it could be all the way out at a customer site. It could be at an office. It could be wherever. And so that's sort of setting the stage for today. As we go to those edge scenarios, how do we make sure that we're still providing secure communication back to a central location? So, just to introduce myself really quick, my name is Mark LeBlanc. I'm a director of technical services at a company called Mobia. Mobia is a system integrator based out of Atlanta, Canada, operating with companies in telecom, healthcare, and enterprise. Personally, I've been part of the HashiCorp Ambassador program for the last couple of years. Great group, great community to be part of. I'm a big advocate for happy developers and engineers. A lot of that comes from my strong belief in the DevOps culture. And from a hands-on perspective, I like to dabble in cloud automation and DevOps, which is really fun because it keeps evolving, which means you're always learning and doing new things. I'm going to approach this through storytelling. And I'd like to introduce you to this fictitious company called Little Big Mining Company. Fun fact, I'll point out, all the images I've used as part of this talk track today were generated with the Midjourney AI bot. And I've got all the prompts in the slide, so you should be able to see how I got them when I share these after. So, Little Big Mining Company, relatively new company. They've got a centralized urban office, some city somewhere, and they've got all these remote sites popping up in the mountains, out in forests. And one of the constraints they have is low bandwidth connectivity, which in of itself isn't necessarily the end of the world, but it shapes how they're going to approach some of the things they want to do. And one of the things they want to do is they want to get proactive in monitoring their equipment. They want to be taking telemetry data from their pumps, from their generators, from their rock truck, from their front loaders, so on and so on. And they want to gather this data so they can do some predictive analysis of things like, when do I have to perform maintenance? When do I have to order a new part? How is this thing performing? And they want to, because of that low bandwidth, they want to process that on applications running Kubernetes local to that remote site. And then by doing that, they get a smaller payload and they can just stream the results back to their central office. So that's kind of the story. And the requirement they have is they've got all these security concerns, and we're going to get into the why. And they've got this requirement to go down the SOC 2 certification path. Normally, if I was in a room in front of people live, I'd say, "Put your hand up if you've been part of this and it was fun," and no one's hand would go up. We're not doing that, but I'm imagining you doing that if I say, "Have you done that and it was fun?" And if I get an LOL in the comments, that would just make my day. Uh, for those of you that don't know what SOC 2 is, we'll cover it really quickly. SOC 2 is a certification program companies go through, and it addresses controls around privacy, security, availability, processing integrity, confidentiality, and I can't remember if I started with privacy, but I'll say it again. I'm not going to read all these little points, but I'll highlight a couple. So under privacy, you have things like access control and encryption. Under security, you have things like intrusion detection. Under availability, you have things like security incident handling, disaster recovery. And under confidentiality, you have things like access controls and encryption. And these are all things that you have to kind of address as you seek SOC 2 certification. So let's talk about why. Why does this matter to a little big mining company? Why would they put themselves through this fun process? Well, first up, we've got data security. If you think about a mining company, and many companies to that matter, you often have a lot of sensitive data. You've got financial information. A mining company might have geological data for tests that they've run and they've gone and done and paid for. They might have employee information. SOC 2 compliance ensures they've got adequate controls in place to protect this data. Next up, we have third-party assurance. SOC 2 is a big trust signal. So if you're working with customers, partners, and stakeholders, being able to achieve and show that you have that SOC 2 compliance, it's an indication that you have adequate controls over your environment, over your data, uh, and it's a trust flag. Next up, many jurisdictions have regulatory compliance for different industries and standards. Going after something like a SOC 2 compliance, it's going to help demonstrate you've got adherence to those requirements. Next one would be contractual obligation. Some of these firms might have many partners. They might actually have a contract that says you will be SOC 2 compliant before we do business with you. So that might be another reason. And the last point that we'll talk about why they might do this is a lot of securities around risk management. Implementing SOC 2 controls can help the mining company identify and mitigate risks related to data security and privacy. And so this is all fine and good. We know the why. We understand that they've got all these requirements they want to adhere to. They want to be able to demonstrate they've got a control. The next question is, how are we going to get there? It's great to say we're going to do SOC 2, but anyone that's been through it knows it's a bit of an audacious task, and it can be painful. And so the good fellows working in the IT department down at Little Big Mining Company, they've decided they're going to leverage the NIST CSF for SOC 2. Now, NIST stands for National Institute of Standards and Technology, and CSF is their cybersecurity framework. And why this matters as part of this conversation is CSF provides a structured approach for managing cybersecurity risk. It was developed through collaboration with government, industry, and academia, and it offers guidelines and best practices for various industries. It consists of five core functions: identify, protect, detect, respond, and recover. And this has a lot of alignment between SOC 2. SOC 2 assesses an organization's adherence to those trust services we talked about: the security, the availability, the processing integrity, confidentiality, and privacy. And those five core CSF functions map almost directly to them. Let's take a look at what that side by side what that looks like. So if we think about the NIST CSF identify function, uh, it maps the control objectives related to establishing and maintaining the control environment, as well as conducting risk assessments to identify potential threats and vulnerabilities. Moving down, protect aligns with control objectives related to access control, encryption, and general data security. Next up is detect. It relates to control objectives focusing on monitoring and detecting security incidents or anomalies in real time and enabling timely response. The next one would be respond. It corresponds to control objectives concerning incident response procedures, including how an organization reacts to and manages security incidents. And then the last one that maps is the recover. So how does an organization ensure they have business continuity, and how are they going to recover from those disruptions or disasters? Now, I've been talking for a few minutes a lot about security frameworks and compliance and certifications. And I want to go back to that initial problem statement of little big mining company having all these remote sites, and they want to stream data securely back to their central office. And I don't know, I've been chatting for maybe 10 minutes or so, and I've yet to mention a HashiCorp product. I'm in the middle of a Hashi talk. So naturally, the next section is going to be talking a little bit about that. And when you think about this on the surface, there's a few different tools we could talk about. We could definitely pull console in and talk about some of the security controls it offers. We could pull in boundary and talk about some of the secure access that it provides. But for me, really, this is talk track around Vault, and very specifically the Vault PKI engine and what that offers to satisfy some of those security controls and concerns we were talking about. And I want to pull this table back up for a moment. And I want to add that a new column that maps that back to the Vault capability. So I'll run through this fairly quickly, and then we'll keep going through some of the specific Vault functionality. So if we think about the NIST identify function, that maps really nicely to the identity-based PKI management. If we think about the protect function under NIST, well, we have a really great centralized holistic key management solution with the PKI engine. Under detect, Uh, we know and we've experienced how comprehensive the Vault audit log is. We can get all that data nicely. Under respond, you have the ability to rotate, revoke those certificates again. That centralized pane of glass that you get with the PKI engine. And then lastly, under recover, we do have the fully automated lifecycle management for those that PKI infrastructure. The other thing worth mentioning under recover as well, if you are using Vault Enterprise, you could be doing things such as rolling out disaster replicas or performance replicas. So that helps address that concern as well. All right, so let's just talk a little through a little bit about exactly what that means. So Vault for identity-based authentication, uh, you get identity-based certificate issuance. So with the PKI engine, you're going to tie that back to an identity that authenticates the vault. So you're going to make sure that somebody or something that authenticates gets what they're supposed to, scope to what they're supposed to. Next up, the RBAC. Uh, the PKI engine integrates seamlessly with the Kubernetes RBAC mechanisms. So you can make sure that specific roles and service accounts, again, get exactly what they do need access to. And because there's a fine grained control over which services can request it, it's pretty tight. Next up, the certificate attribute mapping. And for me, this really speaks quite a bit to the scalability of this solution. So again, think back to little big mining company. They have the central office and they're popping up all these remote sites. But we don't necessarily know how far they're going to go or how many they're going to have. But having a central spot where you can define those attributes, things such as the common name, the organization name, the DNS name, being able to do that in a central spot and have a distribution mechanism that isn't a person logging into a server and configuring them is pretty powerful. Next up, and the last point on the identity piece is the identity federation and integration. So organizations that are using things like LDAP, Active Directory, or cloud-based identity services, Vault integrates seamlessly with those. So if you have an existing identity you need to make sure is tied into that role, you can do that. And I've got some screen grabs, and this is odd for me. I usually show terminal or YAML files for this, but I'm using the screen grabs of the Vault Enterprise GUI today. Um, what I've got up here is just a quick snapshot of what the authentication method looked like. And I want to call attention to that top one for Kubernetes. So remember, I said that little big mining company wants to process that data on appliances running Kubernetes locally. So we're going to enable that Kubernetes auth engine. If I drill down one step further, we can see what that looks like. And so we have a role associated with that Kubernetes auth engine called little big toe stream role, and it's bound to a server's account within the namespace of data streamer. So there'll be some sort of a streaming service that's going to run, authenticate to Vault, get a certificate, and be able to stream that data back securely to the headquarters. Next up, just explaining the setup for this talk track. There's a couple of different ways you could go about this. The way that I've set it up for this purposes, we're using Vault as a CA. So we're using Vault to generate a root certificate that's going to be used to sign the intermediate certificate, which ultimately is going to be responsible for writing those identity certificates. So we play this back in terms of a little big company. That one in the bottom right, what might say remote site 5.littlebigcompany miningcompany.com. And what does that look like from an implementation perspective? So again, looking at the GUI, looking at secrets engines, I've got two PKI secrets engines enabled under different mount points. The first one under slash PKI is for the root, and then there's PKI underscore int for the intermediate. You can do this in the single mount point. I've always just sort of done it with the two, but you could do it with the single point with newer versions of Vault. And then again, so I wanted to sort of play back the VR back mechanisms here. So we have role under that intermediate cert for littlebigminingco.com. That would be associated with a Kubernetes service account, and this role would be allowed to create a certificate for that endpoint. All right, moving into the last kind of few points that we're going to talk about from a Vault capability perspective. Um, and it's around tying it back to that detectability and for compliance. We know that Vault has a comprehensive logging solution. It's going to record all those interactions with the PKI secrets engine, including the certificate issuance, the renewal, the revocation, and any policy changes. And those audit logs capture things like the user or service account performing the operation, the timestamp, and the outcome. You're also getting real-time monitoring and alerting because it's gonna integrate with your existing logging and monitoring solutions, so you can have real-time, uh, alerting of those operations, and organizations can configure alerts and notifications based on predefined thresholds or anomalies, allowing them to react, quickly and diligently. Next one, policy-informed violation detection. You've got, uh the access control policies that allow governance to say who can do what with those certificates. So it's not sort of enable it and everyone can do everything. You would have an administrative team responsible for configuring how that PKI engine works. And then you would have a separate role that allows the issuing of, or rather requesting of. So if I want a certificate as a user, I don't have the ability to configure that PKI backend. I'm only going to be allowed to get a certificate if my role that I've identified authenticated with based on my identity says I can do so. And the last point here is just around the historical data and analysis. Vault can store some of this. You can also ship this off to your logging infrastructure for further analysis. And then just in summary, so to tie it back, I just want to kind of highlight again, we talked about how the NIST CSF function talked for identify. We're getting with Vault a couple of things. We're getting the identity-based PKI management, but we're also getting the Kubernetes authentication as well, based on that identity. For Protect, we're getting that centralized holistic key management solution. For Detect, we have the strong audit log capabilities. For Respond, you get the key rotation management. And because you're tying this into your monitoring and logging infrastructure, you can have some other alerting to respond as well. And then under Recover, you have the automated lifecycle management. You have the capabilities to revoke those certificates that have been issued. And because you might be running Vault Enterprise, you might be running replicas to further satisfy that. So in conclusion, thinking back to a little big mining company with these remote sites looking to run Kubernetes locally to process data, send it back to the central office. They decided, hey, we want to make this a great story, and we're going to go after SOC 2 certification. They said, how are we going to do that? Well, we're going to leverage the NIST CSF framework, which ultimately led them to some great functionality from Vault that satisfies those controls. And thank you. I hope you enjoyed the story. Um, I really wanted to approach this a little differently than some of my typical presentations. I really want to drill into the why of the solution. So the idea here, I hope you take away is Vault's great, but there's a lot of reasons why it's great and why it fits as sort of a solution. If you scan this QR code, you should land on my LinkedIn page. My name's again Mark LeBlanc. I'm with a company called Mobia. Thank you so much for following along.